In this last section of 5.2, we want to discuss the complement of an event and the complement rule. So the complement of an event, if we suppose that S is the sample space of the probability experiment and E is an event, then the complement of event denoted E complement or E bar actually, or E prime, or it's E with a little bar on its head. Let me put that in there. Oop. Like that. Okay, different books call it different things. There we have it. Is all the outcomes in the sample space S that are not outcomes in the event. Right? So everything that is in the sample space but is not in what you were looking at. Okay, well, what would that look like? So suppose you are talking about drawing a single card from a standard poker deck. Just pretend. So you're going to reach into a deck of cards and you're going to pull out a card. If event E is drawing a spade, then E complement would be not drawing a spade. So there we go. Now you could say that in the negative tone. You could say it's not getting a spade. Or you could say drawing a diamond, a heart, or a club. Right? Those are all the things that are not a spade. So that's kind of the more positive way to write it. Now how would it look in a graph? Oopsie, I didn't mean to do that. It would look like this in a Venn diagram. So you have in here in this circle all the spades, and then you have outside in the sample space everything else, the diamonds, the hearts, and the clubs. Okay, so now how does that affect us for writing these up? Let's start with that. So suppose we have rolling a 10-sided die, and event E is rolling an even number. Well, then E complement would be not rolling an even number. But that's kind of a negative tone, so that would be rolling an odd number. Right? If rolling an even number is your event, rolling an odd number is your complement. All right, what about you want to select a person at random, and event E is that they have AB blood. So then the complement of that is that they do not have AB blood. And you could say that not have AB blood, or you could say they have A blood, O blood, or B blood, right? The other three main types. All right, what about having two children, their genders? So I'm going with girl, girl here. So event E is having both girls. That would be girl, girl. Right? So the complement of that would be not having girl, girl. And that means that you have boy, 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 girl, or girl, boy. One of those three. Realize what that means. That means that you're having at least one boy. Because if you do not have girl, girl, you have at least one boy. That terminology is going to come back to haunt you. That's why I underlined it right there. Matter of fact, I'll even highlight it because it's important. All right, now that we know how to write up complements and kind of how they look, we need them to help us find probabilities. So why are the complements so important? Oops, there we go. So complements are important because there is a complement rule for probabilities right here. It says that if event E represents any event, and if E complement represents the complement of that event, then the two probabilities have got to add up to 1. In other words, the probability of E complement, I think I've got this backwards, the probability of E complement is 1 minus the probability of E. There we go. Okay, so now how does that help us? Well, what we're getting at here is the same rule that we learned back in section 5.1, which is basically the sum of the probabilities has to be 1, right? So if you have an event E, let me go back to the spades example. If you have your spades in here and all your non-spades out here, they've got to make 100% by the end of it. Sorry about hitting that mic there. Sorry about that. All right, so let's look at hearts. If you want the probability of heart complement, what you want is the probability of not getting a heart. That's 1 minus the probability of a heart, right? That would be 1 minus, now hearts, there's 13 hearts out of 52 in a deck. So that's 1 minus 13 out of 52. Now you might be wondering, where in the world am I getting 39 from? So let me show you. So if you have 50, or excuse me, 1. 1 is technically 52 over 52, right? Because anything, 1 is anything over itself. So what I'm really doing is 52 over 52 take away 13 over 52. And to do that, I need to do the numerators. So I need to take 52, take away 13, ta-da, and I get 39. So that's 39 out of 52. All right, now what about a face card? I do not want a face card. Okay, so what I'm really looking at here is the probability of face complement. Okay, I want the complement of a face card, which means I want 1 minus the probability of a face card. Okay, well there's 12 face cards out of 52, and you take it away from 1 again. So that would be 52 out of 52, take away 12 out of 52. And again, with the 52 and the 12, 52 take away 12 is 40. That's where that number comes from. Like, the beautiful thing about a fraction in this instance is that it always works out that this number here in your denominator, 52, is always what you're putting in the front. So if you take 52 right there and you subtract away 12, you'll have your numerator, and then the denominator is always 52. You can also use your calculator to help yourself quite a bit, but the calculator will always do a reduced fraction, which wasn't really asked for in this problem. All right, now what about the graduate degrees right here? Well, this is even easier. This is decimals, so we don't even have the fraction business. So I want to know the probability of not getting a random certificate, excuse me, not getting a certificate when I choose a student at random. So I want the probability of certificate complement. That would be 1 minus the probability of certificate. That's 1 minus 0.2117, which is 0.7883. In other words, instead of adding up all these other ones, I figured out that the sum of the entire column has got to be 1, and then I take 0.2117 away from 1, and I'll know what all of these added up to. All of these ones had to make, hold on one second. There we go. All those yellow ones had to make 0.7883. So these 6 numbers you could add up, or you could just take the orange one away from 1 and you'll know what those 6 numbers added up to. That's a very potent tool because it keeps you out of having to add all this stuff for yourself. All right, so now let's use that same logic, but for a contingency table here. So I have the following table shows JC Fall enrollments by degree type right here. So let me undo this real quick so we can see it. So I want the probability of not getting an associate's degree. In other words, I want an AA complement. So AA is right here. I'm going to highlight that in blue because I did it earlier in blue. And you can see there's 1194. And remember that the grand total for the whole problem is over here on the right. It's 6548. So what you can do is you can say, look, if I don't want AA, I mean, I want all the rest of these. Well, if you want all the rest of these, you could add them all up, or you could just take 1194 away from 6548. And that's what we did here. So I say, look, I want 1 minus the probability of AA. That's 1 minus 1194, that's that blue column, over 6548. And we just saw you take the denominator, make 1, that number 1 right there, turn into 6548 over 6548. You subtract away 1194. That gives you 5354 divided by 6548. Again, I can just use my calculator to do that. 6548, take away 1194. And then I could divide that by 6548. Oops, I didn't do that. 5354 divided by 6548. There we go. And then I press math number 1, enter, and it'll turn into a fraction for me. So it's a reduced fraction of 2677 over 3274, or it gave me the decimal of 0.8177. And there we have it. So I don't really want to color this because what I would be coloring is exactly what I already found, right? So it's that zone in there. Hold on. I just wanted to get this all into one line. There we go. Okay, so it's the white zone right here. that you just found. You found what all of those numbers add up to. They add up to 5354. All right, now let's go on and make it a little bit trickier. Suppose I don't want an AA nor an AAS student. So that's both of these columns put together. So let me kind of make them green or something. All right, so that's these two numbers here. So if I don't want either one of these, well, you could add up these four, I know, but we're trying to use the complement rule here. So, matter of fact, I'll even add that. Find the probabilities using the complement rule. There we go. That way there's no question. I'll even add that to this one up here. That way, again, because you could have found this by adding up the other things. I mean, that would have worked, but it would have defeated the purpose of what we were trying to find here. This is to find the following probabilities using the complement rule. Sorry about that. Okay, so let's go back down here. Of course, if I don't specify in an exam, then it's free game, right? You can do whatever you want. So I'm going to use the complement rule. So what I want to do is I want to figure out what these two numbers are, right? If I add them up and take away from 6548, I'll have what this white squishy middle is in between, right? So I add up 1194 and 3986. So 1194 plus 3986, and I get 5180 right here. Then I want to take it away from 1, but remember that means you really end up subtracting from 6548. Because if you look at the table, all these numbers here have to add up to 6548. So if you take the green ones away, you'll have what the white ones add up to, right? So that would make 5180 over 6548. And then if I just take 6548, take away 5180, I'll have 1368. And then if you divide that by 6548, you get about 0.2089. And there we go. We're done with that section. We have learned how to use the complement rule and how to use the general addition rule. And we've also learned what disjoint means and how to apply the disjoint rule versus the non-disjoint rule. I'll meet you back here in section 5.3 for when we have to deal with independence. And that's when you're dealing with multiple events. Everything up to here was drawing one card or drawing one student. I want one student, see, one student, or one student, right? Okay, right here. So if that's the case, a randomly selected student. What if you're going to draw 2 students or 3 students? How does that change? Well, that's what we'll see in the next section. So I'll see you then.